Hey, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 11 from this IGCSE paper 4, specimen paper 4 for the 2025 syllabus. Okay, so this is from the specimen paper, and this specimen paper is for the new syllabus, which changed quite considerably. So this paper 4 now is completely different from the old type of paper 4s. It's only 2 hours long, and it's made up of a whole heap of questions, which some are short, some are long, whereas the old one, they were very long. But anyway, we're going to answer this question. So it's quite a short question, 11A and B. So it's to do with Venn diagrams and set notation. So this is something where I'm going to take a bit of time to explain for those students who need that explanation. So we're given this rectangle, these two circles inside it, one labeled A, one labeled B, and this little 3 outside the 2 circles, but inside the rectangle. And this symbol here, this funny E kind of thing, well, that means a universal set. So that's basically telling us we are looking at what's inside this rectangle. That is all the things that we're looking at are inside this rectangle. And they've told us that the universal set, the count of the elements inside the universal set is 20. So when you have n and then you have brackets and this universal set, is telling you that this is the number of elements altogether inside this circle, or inside this rectangle and circle, the whole thing, right? So that's the total number of elements in the whole universal set. And then it's told us that the number in A union B complement is equal to 3. So this 3 here is not an element, it's a number of elements. And we know that A union B means everything that's inside A or everything inside of B. Okay, so everything inside of A or everything inside of B. So you don't include this intersection twice, you include it just once. So you count all the elements in A, and then you count all the elements in B, excluding the ones here because they've already been counted from A, and that will give you the number in A union B. But when you've got this dash here, this complement, it means whatever's outside of those. So this 3 refers to the elements that are outside of these 2 circles. Okay, so that implies that the number of elements inside A union B, the number of elements inside A union B is going to be 17, because there's 3 outside, there must be 17 inside altogether. Okay, so we don't know where they are. We know in A there are 10, and in B there are 13. Some of the ones in A might be in B. So I can't say, there's 23 altogether in there, but we can understand how to find it quite easily now. And one of the easiest way to deal with this question is you just list them all down and you add them together. So, okay, there's 10 elements in A, there's 13 elements in B, there's 3 elements outside of them. Now that makes a total of 26 elements altogether. Now some of those elements have been counted twice. Those elements have been counted twice. Okay, because they are going to be like in this from both of those. So how do you know how many are counted twice? Well, we know that there's 20 elements altogether. So you're going to take 26, take away 20, and that will get rid of the ones that have been counted twice. That means the number in A intersection B is 6. So the number in A intersection B means the ones that are in A and B. It has to be in both of them. So it's basically referring to this section over there. That's A intersection B. It means it has to be in A and also in B. A union B means it can be in A or it can be in B. So A union B is like this is a smiley face. If it's in A, it's included. If it's in B, it's included. So, if it's in either, you will just, for example, if you had to shade the region, you would shade both of those circles. But A intersection B is like the frowny face, right? So it means it has to be in both. It can't be just in A, and it can't be just in B, it has to be in both of them. Okay, so it's very more strict. This is a more strict condition. So that 6 is going to be here. Those are the people, or those are the elements that are in A and also in B. Okay, which means the ones that are left to go in this section here, which is the ones in A, not in B. The ones that are in A but not in B. Well, there's 10 minus 6, which is 4. And the ones that are in B and not in A is going to be 13 minus 6, which is 7. So we have 7 plus 6, which is 13, 13 plus 4, which is 17, plus 3, which is 20, which matches the number in the universal set. Okay, so we've filled in all those numbers because that's going to help us answer any question that we get. Now it says the number in A complement intersection B. So the number in A complement intersection B. I'll just write it there so we can see the diagram clearly. So what that means is it has to be outside of A, and because this is intersection, it must also be inside B. It must be inside B. It can't be outside of B, but it must be outside of A as well. So if you think about it, that's this region over here. This region over here is a region which is outside of A, but inside of B. Okay, so we're not asked to shade it. I'm just doing this for purposes of your understanding. All right, so this is the region where it's outside of A and at the same time inside of B. I can't include the 6 because then it would be inside A. It can't be inside A. Remember, this is Mr. Frowny Face. This is the one that's strict. Okay, so basically it has to be fulfilling both these conditions. It's not this and or that. It's this and this. They have to be both, not or, and. So it must be both outside of A and inside of B. I can't include anything outside of here because it doesn't fulfill the condition of being inside B. I can't include anything inside here because even if it's in this section here, because it doesn't fulfill the condition of being outside of B, outside of A, sorry. So the only part which fulfills both these conditions, that is outside of A and inside of B, is this section over here. So the number of A complement intersection B is going to be 7. Okay. If the question, for example, was the number in A complement union B, then I would include this. Okay, I would include all of this. Let me just do it in a different color. Okay, I would include all of this. Okay, and all of this. And I would also include everything outside these 2 circles. All of this as well. That's what I'd include. The only thing that wouldn't be included would be that A part. Okay, the part of A which is outside of B. So here this is A complement union B. Why is it like all of this? Because this is Mr. Smiley Face. This is the one that is easygoing, right? So this one here, basically, if it's outside of A, you have to include it. So anything outside of A must be included. So everything outside of A is included. Union with B, which means everything inside of B is also included. So include everything inside of B as well. Okay, even if it's inside of A, even if it's inside A, this smiley face means you have to include it because it's included from this. If it's included from one of them, it must be in, even if the other thing says differently. But here, if it's included, it has to be included from both of them. Okay, if it's not included from any of them, then it won't be included. So I'm just showing you a question that doesn't actually exist here, just for your information. So let me get rid of all of this stuff, put it back as it was. Okay, that's the answer to this question here, because our question was this. Okay, so it's going to be 7. So that's just a little bit of an explanation that's gone a bit, further than maybe what you need for this particular question, but just to give you a more deeper understanding of the topic. And I'm sure we'll face some more set notation questions from this, onwards from this. Okay, so this, as I said, these questions, I'm answering them one by one, and I'm including them in the playlist that will appear at the end of the video over here. So if the other questions of this paper, you can find them in the playlist that will appear in the top right of the screen. Other questions from this topic of set notations and Venn diagrams, you'll find them in the playlist on the bottom right of the screen. You can subscribe to my channel by clicking on this link. And what I will also do here, I'll include my set notations playlist from the old syllabus over there, so you can have a look at some more examples, because this will take a bit of time to get populated for the new syllabus stuff. So anyway, thank you for watching, and see you soon.